Question 10 is from vector. Here, position vector of A, that is OA, is 5 minus 6, and position vector of B, that is OB, is 29 minus 13. We need to find the unit vector parallel to vector AB. So let's find vector AB first. Vector AB can be written in terms of two position vectors, that is OB and OA. Let's write them. So vector AB can be written as vector OB minus vector OA. So now let's put the values. So OB is 29 minus 13, then negative sign, then OA is 5 minus 6. If we do the matrix subtraction, the vector AB becomes 24 and minus 7. 24 minus 7. So now we need to find the unit vector parallel to vector AB. So let's find the unit vector along the AB, because every parallel vector has same unit vector. So we need to find the unit vector of AB. So let's write unit vector along AB, vector AB, unit vector along vector AB is vector AB divided by its magnitude. So now we need to find the magnitude of the vector AB. So we can write modulus of AB, that is for finding the magnitude, is square root of 24 square plus minus 7 whole square, which gives a square root of 625, which is 25. Therefore unit vector of AB is 1 over 25 inside the bracket, that is vector 24 7. So this is the unit vector of AB, or in the direction of AB. And so unit vector parallel to AB will also be this 1 over 25 times 24 minus 7. So first part of the question is done. Now let's go to the next part. Here let's read the question first. The point A, B and C lie on the straight line such that 2 times vector AC equals to 3 times vector AB. We need to find the position vector of C. So let's write 2AC equals to 3AB vector. So if we take that 2 on the other side, we can write AC equals to 3 over 2 times AB vector. Let's write the value. So the value of AB is 24 minus 7. So now let's write AC vector in terms of position vectors, that is OC minus OA. OC is the position vector of C. So now if we times 3 over 2 with the individual components, we get 36, and that is minus let me take the help of the calculator, minus 10.5. okay, so taking the OA on the other side, we can write 36 minus 10.5 plus OA. So OC equals to, let's use the value of OA, so we can write 36, then minus 10.5 plus OA is 5 minus 6, so minus 6. Now doing the matrix addition, we get OC equals to 36 plus 5, 41, minus 10.5 minus 6 is 16.5. So this is the position vector of OC. So question 10 is done. Now let's move on to solve question 11.